Hello, welcome to the math channel, the math tutor here. Today we are going to continue with the series on differentiation, and today we are going to talk about another rule of differentiation, and that is called the chain rule. The chain rule. Okay, we are still continuing. I think here there is misspelling. Alright, it is chain rule, just like this. Okay, this is an I. Okay, yeah, we are still continuing with differentiation and the rules. Talked about the power rule, scalar multiple rule, and now we are talking about the chain rule. Okay, this is how the chain rule is. So dy dx, you all know by now, if you've been following this series, that dy dx is the same as differentiation, and the answer you get after differentiating is called the derivative. So dy dx is dy du times du dx. Now this du is a variable, it changes. Sometimes it is depending on what you are solving. Sometimes it's ds, sometimes it's dk, dp, anything, alright, any letter, but the constants are these ones, dy and dx. I've told you that this part varies depending on the question. Okay, we shall go right away to an example. Find dy dx, and then our first one will be y is 3x minus 2 to the power of 7. Now this chain rule mainly saves time. It is shorter and saves time, because thinking about this question that we are about to solve, you can expand it, you can expand, normal expansion, and then you differentiate it like we did in power rule and scalar multiple rule, but it will take a long time, and it will take a lot of space. And since in an exam you are limited with time, so time is part of the exam, so you need to find ways of doing it quickly and in a shorter way, but correct way. Okay, so we can start by saying let u, like I told you, the u is a variable that can change. You can say let p, let s, let k, whatever you choose. So you always let the bigger expression, 3x minus 2. So in this question, the bigger expression is 3x minus 2. Okay, so let u equal to that. So that means that y will equal to u to the power of 7. Alright, so now du dx, differentiating this, differentiating u with respect to x, whatever is on the left gets the top, and whatever is on the right gets the bottom. So we shall get 3, just 3, applying all the rules, the scalar multiple rule here, we shall just get a 3. Okay, okay, let me erase and I show you how we get the 3. This is how we get the 3. We shall say 3 dx minus 2 dx to the power of 0 dx. Right, we did this in, say, the first episode and the second one. So here we shall just get 3, because dx is 1, and here the 0 comes, multiplies the 2, so here we get a 0, so we just get a 3. So this is du dx. Okay, and now dy du, this part here, will be 7u6, u power 6, because it is 7 minus 1. So finally dy dx will be dy du times du dx. Here is our chain rule, we are applying it here. So dy dx will be dy du, and dy du is 7, okay, but u is this, so we write 3x minus 2 to the power of 6 times 3. So our final derivative will be 21 into 3x minus 2 to the power of 6. This is our final derivative, and this will be our answer. I hope you are understanding and following. Let's continue with another question, applying the chain rule. Okay, question 2 will be find the derivative of y equals negative 2 over, should we make this a negative? No, don't worry about it. Yeah, it will not be a negative. 2 over 3x squared plus 1 all to the power of 5. So like we said, you let u be the bigger expression, so this will be 3x squared plus 1, okay, meaning that our y will be 2 u to the power of negative 5. Remember, we have to apply the rules of indices like you had them before in that chapter of indices. Okay, so let's start. Du dx will be applying the power rule and the scalar multiple rule. We get 6 here, x, okay, the 1 will be a 0, and dy du here will be negative 10 u power negative 6, because here we subtract a 1, so we get a negative 6. Negative 5 multiplies a 2, we get that. So dy dx will be dy du times du dx. Alright, so this will be dy du negative 10 in brackets. What was u? U is 3x squared plus 1 to the power of negative 6, and what is du dx is 6x. Right, so our dy dx now will be negative 60x into 3x squared plus 1 to the power of negative 6. Okay, so this would be the answer for this. Hope you're following, and I hope you are enjoying the application of the chain rule. Alright, so let's do one more. Okay, let's do one more. I hope this will be enough space. Okay, so if it's not enough, we shall erase and continue. So the curve y equals root ax plus b passes through the point. The point is 12, 4, and has a gradient of 1 over 4 at this point. Okay, this point. So they want us to find a and b. Okay, they want us to find a and b. Alright, so let's try to solve this. Okay, solution. Remember, I told you dy dx the same as gradient of a curve. So when they say find the gradient of a curve at a certain point, we have to differentiate and find the derivative. Okay, so let's start. Y is equal to the square root of ax plus b. Okay, this is the equation that they gave us. So given that the point is 12, 4, this is x, this is y, so our y will be the square root. Okay, let's just substitute immediately with the coordinates. So 4 is the y, is equal to the square root 12a plus b. Let's take this to be equation 1. Okay, Okay, so this is equation 1, but also remember that y is the same as a plus ax plus b whole power half. This here is exactly the same as this. Okay, so there's no problem with that. So let u equal to ax plus b, you understand? And that means that y will be u power a half. Okay, this is u power a half. Okay, alright, so let's try to leave this step equation 1 here. Let's first deal with this part. Okay, so du dx will be a. Okay, a is a number, b is a number, so if you differentiate this you get a. Okay, I hope you're following. And then dy du, the second part will be half u to the power of negative half. Okay, I hope you're following. We have these two equations here. So we know that dy dx chain rule will be dy du times du, just a minute, dy du, yes, times du dx. This is the chain rule. Okay, so let's put in our du dx and dy dx and we see what we have. So dy dx will be dy du as half u to the power of negative half, don't worry about it, we shall get to everything, times a is du dx. Alright, yeah, so this is our dy, this is our dy dx. Alright, now let's plan and okay, let's write it in a simple way. So this will be this can be a over, okay, a over okay, it is half a this is into the square root of u. Okay, the square root of u, and the square root of u is, remember our u was this part here is our u, so we write ax plus b. Okay, we have written this into simpler version. So this is dy dx. Alright, okay, is everything okay? I hope everything is okay. Alright, so now that we have our dy dx, remember we said that dy dx is the same as gradient. Okay, this is the same as gradient. So let's solve. So we say half a all over, okay, it's just a, okay, let's just say a over 2 root a over 2 root just a minute, I need to be neat so that you can follow and understand. So we can say a over 2 root ax plus b equals 1 over 4. Okay, now we are going to substitute. Alright, we are going to substitute. Remember at the beginning we had substituted the coordinates of 12 and 4 and we got 12a root 12a plus b all over is equal to 4. So we are going to substitute the y, the x here. Let's put in the x here in this. So when we substitute the x here, we shall have a into, a over 2 root 12a plus b is equal to 1 over 4. Alright, we've substituted the value of x. Remember the coordinate is 12, 4. So x is 12, so we've substituted the x. And now let's simplify this. So simplifying this will be 4a is equal to 2 root 12a plus b, dividing by 2 on both sides. The 2 cancels. We shall now have 2a equals the root of 12a plus b. Now this here is our equation number 2. Remember, we have equation number 1 here and we have equation number 2 here, so we can now solve both simultaneously to get the value of a and b. Alright, so we can write both here. So 4 equals root 12a plus b. This was equation 1. And equation 2 is 2a equals root 12a plus b. This is equation 2. So being that the right hand side is the same, so that means that even the left is the same. So 4a is equal to, I beg your pardon, quickly, sorry for that. So it means that 4 is equal to 2a. So dividing by 2, a is 2. So we've got the value of a quickly. Now going back to get the value of b, we can use any of what we have. We can use the equation 1. So from equation 1 we shall now have 4 is equal to the square root 12 times 2, since a is 2, plus b. Okay, alright, so 4 is equal to the square root of 24 plus b, and now we can square both sides to get rid of the root sign. So 16 on the left is equal to 24 plus b. Okay, so 16 minus 24 is b. So our b will be 24 minus, 16 minus 24, sorry about that. 16 minus 24, so our b will be negative 8. So we've got the two values which the question required. So this was a bit longer, but I hope you followed the steps and I hope you understood. Alright, so see you in our next video about differentiation and another rule. Okay, I hope this was okay. We started by talking about the chain rule and we see how it is represented. We saw how it is applied in 2 questions. Alright, 2 questions. Were they 2? No, they were 3 questions. Oh my god, there were 3 questions. Alright, so I hope you understood. I hope you check out some more questions and practice. See you in my next video. Bye bye.